All right, folks. Good morning. Hope you're all doing well. We are going to just try to jump right in this so you guys have time to do this. But basically, you have a sub, but here's your notes. We'll just go through them together. I'm going to go like through it and not like pause like I do in class. So I would just pause your video when you want to write something down. Otherwise, I'm just going to kind of keep going to keep the video from being super long. So if you need to pause and write something down, just pause me, write down what you need, and we'll go through some notes. We'll go through some problems. We'll talk about some stuff. And then you're going to work on some homework right out of the book. You have a unified day on Monday. So we have all of our classes. So you'll have my class on Monday. So this homework is due on Monday. And let's go. Let's do this. I'm going to share my screen with you. Hopefully you can see that. And yeah, we'll go from there. Oh, don't go right there, please. Okay. All right. Worked out. Okay. So let's skip that. Okay. Let's jump into it. So we're on section 1.5. We're talking about angle pairs. Angle pairs. All right. Angle pairs. So here's our first angle pair. This is number one, the first set of angle pairs we're talking about. Adjacent angles is a pair of angles that share a vertex and a side but do not overlap. Okay? So again, pause, write that down, and then unpause and listen. So basically, really straightforward. They share a vertex, right? We could label this point A. They share point A, okay? And they share this side, right? If this was a ray, like if this was ray AB, they share that side. Okay, they share this ray, they share the vertex A. They don't overlap, right? We have two angles here, they're separate. They got their own thing, right? One's angle 1, one's angle 2, they're separate angles. So that's adjacent angles. Pretty straightforward. But again, everything, this whole first chapter we do, guys, is just so important with all these foundational pieces of like, what's an angle, what's a segment, right? So all this stuff is really good because we'll use these vocab words. Next up, we have what's called a linear pair. A linear pair is a pair of adjacent angles whose non-common sides form opposite rays. Okay, so this here, again, pause if you need to. This here is their common side, the side that they share, okay, this ray. Their non-common sides, we'll put it in red, are these two, right? These are their non-common sides. Okay, these form the opposite rays. Okay, it forms a straight line. It forms a 180-degree angle. Okay, so this is really important. We're going to talk about linear pairs all year. That is a linear pair. They have to be adjacent angles too, right? So they have to be next to each other. They have to form opposite rays. So they have to add up to 180. Okay, and we'll see this come up a ton. Two angles who add up to 180 degrees. Let's keep moving. Vertical angles, also super important. Vertical angles are non-adjacent. So now they're not next to each other. They're actually across from each other, and they're formed by intersecting lines. So angles 1 and 2 are vertical angles, right? They're across from each other. And then 3 and 4 are vertical angles, okay? So they're the angles that are across from each other, not adjacent. And this is really important here, is that vertical angles are always congruent to each other. They equal the same thing. Someone brought this up in one of our classes, that this happens. So if we wanted to, we could draw our little congruent symbols, right? So these guys are congruent to each other. And then these ones are congruent to each other. Sorry, I know that arcing looked really weird. Ran out of room there. So opposite angles, if they're vertical, are congruent. Okay, they're equal to the same measure, right? So this could be 100. One is 100 degrees, and two is 100 degrees. And then what do we know? What are 1 and 4? This is a big question here. What kind of angle pair is 1 and 4? What? I heard someone in the back say it. Yeah, they're a linear pair, right? So 1 and 4 are a linear pair, and 3 and 2 are a linear pair. Same with 1 and 3 and 2 and 4. So we also know that angle 1 plus angle 4 add up to 180. Because they're a linear pair, right? And we know angle 2 and 3 add up to 180. So we can keep going and we have all these things that we could write down. Okay, we have all these things that we can write down about vertical angles. So if we have vertical angles, we know we have all these angles that are congruent, right? Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And then we also have all these linear pairs. So if we get a little intersection like this, sorry, my handwriting is so bad with the mouse. It's been a long time since I've had to do this. But we can get all this information from just a small little picture, right? It's pretty crazy. So that's vertical angles. Summed up pretty quickly, but still, it shouldn't be too bad. Moving on. Okay, now we have another angle pair, which is complementary angles. Complementary angles are two angles whose measures add up to 90 degrees. Okay, so pause, write that down if you need it. So they form a right angle, right? We got our little right angle box over here on the 1 and 2. So we know these have to add up to 90. But complementary angles don't need to be adjacent, right? They do not need to be next to each other, as we can see with A and B here. A and B are complementary, but they are not adjacent, and that's okay. Linear pair needed to be adjacent, okay? But our complementary angles do not need to be adjacent. And that leads us right into our next one. What? Someone said it. I heard it. Supplementary. Okay, so supplementary angles are two angles that add up to 180 degrees. It can be a linear pair, or it doesn't have to be, right? So we can see 3 and 4 are a linear pair, right? So they're supplementary, right? But they could also be separate angles. P and Q are also separate angles, okay? So it's just two angles that add up to 180. They can be a linear pair, but they don't need to be. But if we go back and we look at our linear pair, all linear pairs are supplementary, right? Maybe you want to add that back up in your notes. All linear pairs are supplementary. Whoa, gosh, that A was difficile. Oh, it looks so bad. Okay, all linear pairs are but not all supplementary angles are linear pairs. I'm just going to paraphrase and just do it like that. Okay, so that's a little bit about how that all works. So we got complementary, we got supplementary, vertical angles, linear pairs, adjacent angles. Oh man, so much good stuff, huh? Okay, we got one more thing here, and then let's look at some problems. So one more thing to write down, then we'll look at some problems. There's a lot of information, but again, you can just pause it, write it down, and then listen. Perpendicular lines intersect to form four right angles. 1, 2, 3, 4, okay? They intersect to form four right angles. And then they're all congruent, right? All of these, if you see one right angle, you know that they're all going to have to be 90 if they're in this, right? Because we know the ones next to it are going to have to be 90. We know the ones across from it are going to have to be 90. So we got all these 90-degree angles, right? Or 90-degree angles. Absolutely. Segments and rays can be perpendicular to lines or other line segments, so they don't always have to intersect fully like this. All right, you might get something that looks like this, where you get a right angle like that, and now we have a ray intersecting a segment or a ray intersecting a line. Doesn't always look like full vertical angles. Could look like this too. Ooh, excuse me. All right. And then again, you have the red right angle thing that shows perpendicular, but this symbol also shows perpendicular. Okay, so you might see this in your book. Well, like upside down T. So you read that is like line AD is perpendicular to line CB. That's how you read this whole example. So you might see that little upside down T as well to indicate two things are perpendicular. So those are perpendicular lines. Also super important. All right, so let's do a couple example problems here. And then, yeah, we'll have a couple example problems. These are all good. We'll talk a little bit about that, and then we'll call it a day. And hopefully, you know, you've been pausing this and stuff, so it should take you longer than what we've done so far. So we want to name an angle or angle pair that satisfies each condition. So two adjacent angles. Well, let's see, we could say something like angle LTN, right? And NTE. So those would be two adjacent angles, right? So that would be a one. There's plenty of pairs, right? You could do STE and NTE. You could do RTS and RTL. So you can do any of that stuff. Two acute vertical angles. Be careful on this one, right? RTS, we're going to use RTS. What is RTS vertical width? This ray is just bisecting this bit, but the vertical angle is the whole thing, right? So if we were to draw what RTS was congruent to, it'd be this whole bit, okay? RTS and LTE are going to be the two. Okay? RTS and LTE are the two acute vertical angles. Two supplementary adjacent angles. We're looking for angles that are basically a linear pair, right? They're next to each other and they're supplementary. So you could just say, we're looking for a linear pair here. Well, we could use RTS again, right? And then you have two options if we use RTS again. You could go left or right. So RTS and RTL would work. RTS and STE would work. Both of those form linear pairs. Let's use RTL. Okay, those add up to our RTL is 110. So that means RTS has to be 70, right? They got to add up to 180. Okay, so that's how it looks for number 3. Number 4, an angle supplementary to RTS. Well, we already named one, RTL. We could name the other one, which is STE. Those would be supplementary. Those would be supplementary. Okay. There's some problems. Okay, we could have a problem like this too. This is kind of more similar to the last homework you did. We know these two angles are complementary, right? So what are they going to add up to? They're going to add up to 90. So we're going to just do 3x plus 8x plus 2 equals 90. And we just got to solve for x. We get 11x equals 88. So x is 8. All right, so we found x, and then they want us to find PQS. We could plug it back in. PQS is going to be 24. And then that means SQR is going to have to be what? 66? Does it have to add up to 90? You could also just plug it in too to check yourself, but they gotta add up to 90. So that is a quick little problem there that you might have, algebraic problem that you might have on your homework. We don't have to go crazy here. I think we kind of got this down. So I think we're okay with this example. Let's move on to these. These are tricky. Let's just look at one at a time. You will have a couple of these on your homework. We're working on writing an equation. This is, again, more algebra based. You should have done stuff like this in algebra, but if this is new to you, you're okay. We'll figure it out. Two angles are complementary. So we know already that they add up to 90. So let's start with that. Two angles add up to 90. The measure of one angle is 21 more than twice the measure of the other angle. Okay, so we got one angle, right? That's twice the measure of the other angle plus 21 more. Okay, right? This is 21 more than twice the measure of the other angle. 2 times x is twice, then is 21 more than the other angle, which we can just also call x. Try to just do these with one variable. I mean, you can make them with two, but it makes it more complicated, right? These are related. This one's twice plus 21 more than this angle, so we can use the same variable. So now we can just add these up. So we get 3x plus 21 equals 90. Okay, so 3x equals, what is that? 69. So x is 23. Okay, that's our small angle right here. And then if we want to plug that in to get our other angle, we can plug it into this. We could call this y now. 23 times 2 is what? 46. 46 plus 21 is 67. Okay, so we get 67, and then we can double check. Do these add up to 90? Are they complementary? Yes, they are. 23 plus 67 is 90. Okay, so we have problems like that as well. Should we do one more of those? These can be kind of tricky. Supplement of an angle. So it adds up to 180. Has an angle, has a measure 78 less than the measure of another angle. Okay, so we got one angle, and then we know the other one's going to be 78 less. So we can do x minus 78. This one's not too bad either, huh? Ooh, sorry for the drawing, it's so bad. So when we add those up, we get 2x minus 78 equals 180. Let's see. I do have a little cheat sheet here. So 2x is equal to 258. And then we divide, and we get x is equal to 129. So we know one of the angles is 129, that's this one. And then we got to find this one. So to find y, we do 129 minus 78, just plug it into here. 129 minus 78 comes out to 51. So there we go, we found our two angles. It can be tricky to start on these sometimes, but again, just look at what it says, make a little equation, stick to one variable, and it shouldn't be too bad on those. All right, let's talk about one more thing and then we're going to call it because it's getting close to 20 minutes. Hopefully it took you longer because you're pausing it and writing it down. So we have talked quite a bit about, like, we can't always assume everything or things aren't drawn to scale. But let's talk about what can be assumed from a diagram. So some things that can be assumed are all your points are in the same plane, right? It's a flat surface. We can assume, like, if points are on a line that they are collinear. We can assume that angles next to each other are adjacent angles. We can assume that, like, if we know these are a linear pair, right? We know that these guys are a linear pair. Sorry. We can't assume that that's 90 degrees, but we can assume that these two, I don't want to put congruent. We can assume that these two are a linear pair, GHL and JHL. We know they add up to 180 because they form a straight angle, right? GHJ is a straight angle. We can assume that. So we know the other things are add up to a supplementary angle. Things we don't want to assume on the other side. We don't want to assume any congruency unless they tell us things are congruent or they do the arrows. So if you don't have anything like that, don't assume things are congruent for segments or angles. Okay. Also, do not assume things are perpendicular. Yeah, that looks like 90, but it could be 91 degrees, right? We had one of those come up the other day when we were using the protractor on the board. It can look really close, but not actually be 90. So we can't assume stuff like angle measures or congruency, but we can assume kind of all this other stuff. Okay. I hope that wasn't too fast. If it was, maybe just watch pieces again if you're stuck on something, or send me an email. Probably be responding to my email today if you need help in that situation. Otherwise, I hope you have a great day. Good luck on your homework and all that. And we'll talk to you later, and we'll see you later. Hope you have a great one.